Welcome back. So we're trying to find using the discriminant to determine the number of solutions and type of solutions to a quadratic equation. So remember, ax squared plus bx plus c equal to 0 is your standard form. The discriminant is actually the b squared minus 4ac, which is the portion under the radical of the quadratic formula. Some basic key features. If b squared minus 4ac happens to be greater than 0 when you do the math, you have two real solutions. If b squared minus 4ac equates to an answer of 0, then you have one real solution, which means we have a double root. If b squared minus 4ac results being less than 0, which means it's negative, your resulting answer is negative, you have two imaginary solutions. So we're going to use this information to figure out what are discriminant values, how many solutions do these examples have. So example A says 2x squared minus 5x plus 9 equal to 0. First thing, our A value is a 2, the B is a negative 5, and C is a 9. I'm running on my equation, b squared minus 4ac, an underscore, and then 0. And the reason I did the underscore is because I don't know if my answer is going to be greater than, less than, or equal to 0. We're going to substitute in, so negative 5 squared minus 4 times 2 times a positive 9. Remember, a negative in a parentheses squared becomes positive 25. Negative 4 times 2 is negative 8, and a negative times another positive is still negative 72. This results in a negative result piece right here because I had $25, but I spent 72, resulting in negative 47, which happens to be less than 0. So for this answer, we have two imaginary solutions. On B, we need to first move everything to one side. So I'm going to add x and subtract 2. So we become 3x squared plus x minus 2 equaling 0. Again, identify your A, B, and C. So our A is a 3, B is a 1, C is a negative 2. And we substitute into the formula b squared minus 4ac. We don't know what our answer is, so I underscored to 0. We substitute in, so it's going to be 1 squared minus 4 times 3 times negative 2. 1 squared is still 1. Negative 4 times 3 is negative 12, and then a negative 12 times a negative 2 makes it positive 24, where 25 is greater than 0, so we have two real solutions. On C, I use decimals because I don't like giving you guys easy problems. So first thing we're going to do is we're going to move everything to one side. So I'm going to add 1.2x over, add the 0.1. So we get 3.6x squared plus 1.2x plus 0.1 equal to 0. Now remember, I said if you don't like working with decimals and fractions, get rid of them. So notice the decimal place value. It's one decimal place for all of them. Since they are in the tenths place, you're going to multiply everything by 10. So we become 36x squared plus 12x plus 1 equal to 0. So now you're dealing with whole numbers. So A is a 36, B is a 12, C is a 1. Again, your equation, b squared minus 4ac underscore 0. B happens to be a 12 squared minus 4 times a 36 times a 1 underscore 0. 12 squared is 144. Negative 4 times positive 36 is a negative 144 times a 1 is still negative 144. So we get 0 equals 0. So we have one real solution, which means it's a double root. Example 4 says f of x equals x squared minus 3x plus 1. In this problem, they want us to first find the discriminant to determine if it has any x-intercepts. B, find the x-intercepts if they exist. and C, find the y-intercepts. So we're going to start part A. On A, we take our original equation, which is f of x equals x squared minus 3x plus 1. We're going to identify our A, B, and C. A is a 1, B is a -3, and C is a 1 as well. But it says to determine what is the discriminant. So b squared minus 4ac underscore 0. We want to know how many solutions we have. B was a -3 that we are squaring, minus 4 times A, which is a 1, and C, which is a 1. Remember, -3 is in parentheses, so when you square it becomes positive. -4 times 1 is -4, times another 1 is still -4. So we have 5 happens to be greater than 0, so we have 2 real solutions. So now that leads us to part B. B says find your x-intercepts. So part B, we're going to use the quadratic formula. X equals -b plus and minus b squared minus 4ac all divided by 2a. So negative, and the b happens to be a -3 plus and minus. Now, the b squared minus 4ac, we've already figured out that answer. The answer is 5. So I'm just going to write square root of 5 all over 2 times my 1. Negative times a negative makes it positive 3, plus and minus square root of 5 over 2. There are our x-intercepts. We have 2 of them. Then part C says find your y-intercepts. So you take your original equation, which says f of x equals x squared minus 3x plus 1. And remember back in chapter 2, chapter 3, when we were talking about graphing linear equations, y-intercepts, to find the y-intercept, you're going to make the x values equal to 0. So f of x, we're plugging in a 0 for the x, 3 times another 0, plus a 1. So we have 0 minus a 0 plus a 1. So our f of x value is a 1. So our y-intercept is at 0, 1. So for our last example, it says solve using any method. And of course, I was going to pick a fraction problem. So it says 1/4 x squared minus 1/2 x plus 1/3 equal to 0. Remember, if you don't like working with fractions, get rid of them. First thing you want to do is look at your denominator. So I see a 4, a 2, and a 3. And I look for an LCD. The LCD in this instance is 12 because 4, 2, and 3 all go into the number 12. In order to get rid of your fractions, multiply every single piece by 12. And I didn't bother putting the 12 on this side because 12 times 0 is still going to be 0. So 12 times 1 is 12, divided by 4 makes it 3x squared, minus 12 times 1 is 12, divided by 2 is a 6 with an x, plus 12 times 1 is 12, divided by 3 is a 4 equal to 0. Now we have our A, B, and C. So you can either use completing the square or the quadratic formula. In this case, since I can figure out what my A, B, and C is, I'm going to use the quadratic formula. So A is a 3, B is a -6, and C is a 4. Take your equation, x equals -b plus and minus b squared minus 4ac all divided by 2a. So we have, we're going to use substitution, so it's negative and in parentheses -6. Again, -6 is going in parentheses, so you can square it. So it's -4 times r3 times r4. All over 2 times r3. Simplify your math here. So we have x equals a negative and a negative makes it positive 6. Plus and minus. So -6 squared is a positive 36. And then we see -4 times 3, that is -12. And -12 times a positive 4 is -48 over 6. Just by looking at the math inside here, I'm losing money, so I'm going to be a negative in the radical. So I have x equals positive 6 plus and minus. I had $36 but spent $48. I am short 12 all over 6. This right here tells me that my parabola, when we get to that section, will be floating in the air because our discriminant happens to be less than 0. Here we are going to break down the negative 12. So I'm going to rewrite it as a positive 4 and the radical a positive 3 because 4 times 3 is our positive 12, and then our negative 1. Six comes down, plus and minus. Square root of 4 we know is a 2. That negative 1 the radical, that is our imaginary I, and then radical 3 all over 6. Split this into 2 pieces so that you can reduce your fraction. So 6 over 6 plus minus 2i radical 3 over 6. So 6x equals 1 plus and minus I radical 3 over 3.